Hi everyone and hello, welcome to this video. So just to recap from the last time, we just outputted the name of our device, right, which was the name of our GPU right over here somewhere. What we want to do in this video is kind of create a swap chain, right, and to have some color on the screen. Basically, we just want to clear the swap chain buffer and present it to the screen. So it will be some color. It's not important. What's important is that we actually have a swap chain configured. So you might be asking what is swap chain actually, and I'll just quickly explain it. What swap chain is, let's say that we have configured a swap chain for double buffering. Let's say we have buffer 1 and buffer 2, and this is our screen, right? Screen. So what happens is we can actually we're rendering to this buffer. While we're rendering to this buffer, we're presenting this buffer to the screen. And when the screen is finished, the frame is presented to you, right? Then they're switched, right? And then we're rendering to this buffer while this buffer is presented to the screen. And switch is usually going to happen whenever there is a blink period of your screen and it says, okay, now I can switch the buffers. So usually, let's say that screen is running at 60 Hz per second, right? So this blink period will happen every 60 frames per second. So it means whenever we hit this 60 Hz, our swap chain buffers, right? Our buffers are flipped. So if we were rendering to this previously, then this one is presented to the screen. If this one was presented to the screen, then we're rendering to it right now. And every frame, they're just being flipped. So while that's true, what also can happen, we can actually do single buffer, right? Screen, and then here, and then we render to this one. If we have single frame buffer, usually if you do that, you would have screen tearing. Why? Because right, you're rendering to it while it's being presented to the screen. So it might mean, okay, you rendered to this point right here, and now it's presented to the screen, and then the next frame is being rendered here. So usually you might have some offset from the top of the picture and the bottom of the picture because, right, your game is running too fast or whatever, right? You quickly turn around and then the frame is all kind of wobbly. So that's also a possibility, but you can also like set up triple buffering, etc. We're not going to do that deep into it. We're just going to configure double buffering and do this vsync. Without vsync, this is still kind of like doing double buffering, but it doesn't respect this present like this vertical blink of the screen when it's supposed to switch buffer, so you might still have screen tearing. Oh, of course, this is 60 Hz because it's very common for the older screens. Now it's common to have 120 as well or higher. So let's start with it. And then what I want to do is just move some stuff out from here, especially this device creation, because we're going to have our renderer. So let's just create a renderer class. Nothing too fancy. What we want to do is just move some of this stuff to render. So I'm just going to move this here, this as well, and this as well. We don't want to move like library import, but I want to move this to our renderer. So in our renderer, what I want to do is just copy paste this, and then we're going to create a class renderer. And we will just want to move some of this stuff to render. This device and context, we're going to need it. And we can make this private. And then we're also going to have public, right, for our constructor. But what we want to have here is SDL window. We're going to need it. Doesn't recognize it because it's here. So if you do control dot here, it will do auto suggestion, and then we're going to have frame buffer width and frame buffer height. So let's do that. We're going to pass that as parameters. Frame buffer width and frame buffer height are going to be, as the name says it, the width and the height of our frame buffer. Which frame buffer? The one that we rendered to, right? It doesn't have necessarily to be same as our window, right? If you ever play the game, you might work with full screen, which is usually like some higher resolution, but then you might lower resolution for your game to run faster. Or you might even go for higher resolution but render the smaller screen, in which case it's called super sampling. We're going to need that. So we are going to need this, and then we're going to need void create device. And we can name it end context. And then let's create definition in our renderer, but we also need definition for instructor. So let's just implement this. Okay, it's almost implemented. So just set variables, right? And then call this method. And how this method will look like, well, we already have everything right over here. So copy from the feature level from the last time until this check for our device and context. And this we're going to get rid of. We don't need it. All right. What I want to do is I'm just going to return here. So proper error handling, I'm not going to spend too much time on it because it takes time, and my focus is on DirectX, not the proper error handling. So while I would encourage you to do proper error handling, I'm not going to do it. So I'm just going to say blah blah blah, it failed, and if it failed, we're going to catch it at some point. So this for me is fine, and here device is created, context is created. Good. So further, we can actually start with our swap chain. I just want to get rid of this here. And then what we're going to need here in our header is stuff that we need for our swap chain, DXGISwapChain. So we're going to need swap chain, we're going to need render target view, and we're going to need back buffer. So the swap chain is actually entire swap chain, right? It says, it describes how many buffers do we want to have. It describes the format of those buffers, size, tra la la la. Back buffer is actually our buffer, right? Our texture, which is swapped each frame. So on the frame 1, this will be buffer 1, on the frame 2 will be buffer 2, and on the frame 3 will be again buffer 1 if we're using double buffering. If you use single buffer, it's always going to be same. And if you use triple buffering, which is also a possibility, right? Frame 1 is first buffer, frame 2 is second buffer, frame 3 is third buffer, frame 4 is again first buffer. Depends on the setup, right? It's a bit more intricate, but for us, it's going to be very simple. And then the render target view is just view into this buffer. With DirectX, you create these target view objects to actually view the contents of the texture. And then we, of course, need method create swap chain. So let's do that. And let's go to it. So what I want to do is do this comp pointer. And we're going to use this object, but I'm going to use the second, and it cannot find it. So let's go here. So we're just going to edit. If you check here, GI, I think it's 1.2. That's okay. It is. So just to explain this quick. So this is just versioning of the called DirectX library and everything associated with it, which is DXGI. DXGI is actually for working with the screen rather than DirectX itself. But what this means is kind of like it's versioning, right? You have Windows 7, so it might be DXGI, then you get Windows 8, it might be DXGI1, and then you get Windows 10 or whatever, you might get this interface, and it's just the methods got extended, right, for the new functionality. So in order to not break the old stuff, they had to add the new stuff, and usually that's how they version it. It also means right over here. So let's say that you're working with older DirectX version or older screen version, it might be something like this, but then when you work with the newer, it might be like this, then the new version like this, and going all the way to, I guess, I don't know, it can go quite far. So just to explain, this is same as create new ID of, right? So this is just a macro for doing this, right? So you don't have to like define this interface and then this pointer, because IID, right? It says interface ID, I guess, of this, and then this is pointer arguments, right? And then we pass arguments. So if it has here some third argument, right? You might need to pass here third as well. So this macro just does this. While we're here, we might explain these COM objects a bit. So because you're going to be working with COM objects when using DirectX, I guess it's fair question to explain what COM object is. So it's just a binary format for Windows. What that means, binary format? Let's say you wrote C++ code, then you compile it, it's in binary, right? You use C#, compile it, it ends up in binary. You use something else, compile it, it ends up in binary. And then for that binary format, you kind of write interfaces, right? C++ interface, then you could write C# interface, even like PowerShell interface, right? Let's say PowerShell. You write interface to actually use this object, and that's what COM object is. It's very simple. And then you're also going to see COM pointer. COM pointer is just a smart pointer which does reference counting, right? And whenever reference goes out of the scope, it decreases the pointer. Whenever you create a new reference, it increases the pointer number, right? It has some internal numbering. So let's say you paste a reference somewhere, it increases the number, and when the number gets to 0, it actually releases the object. So it's kind of like smart pointer C#. It's nothing spectacular. So I'm going to leave some links for this COM object so you can read about it. It's very common to work with it with DirectX. So here we're just going to say fail to create factory, maybe result, if this even shows result. But if I run it, I guess we can say create swap chain here. And then what we can do is go back to our DirectX game and create the renderer right over here. So if you press Control dot, you can do this. Renderer. So if everything is all right, it shouldn't have any message. That means that our factory was created, and we can place it here. Let's try it. No symbols loaded. This is interesting. Let's see. But it says okay. I guess it's created then. Okay. So it means just the box symbols are probably loaded. That's fine. Okay. Let's start with our swap chain. So how do we create a swap chain? Well, we're going to need a bunch of information, but we use that factory and then use create swap chain. And here you have number of functions for creating a swap chain, but we're going to use this one. So the difference, right? There's a difference based on parameters, but let's just focus on this for the H window, and this is handle window, and this is core window. So for example, this one is used for Windows 32 apps, this one is used for Windows Store apps, right? So we want to do Windows 32 app, so we're going to use this, and here you're going to see number of parameters. First of all, device. Every COM object actually uses IUnknown, so it's very common to see IUnknown, but we actually pass our device. This is handle to our window, which we're going to get from the SDL, right? SDL is a wrapper around window. So for example, on Mac, it wraps around Cocoa, on Linux around X11 window. Here it wraps around Windows 32 window, so we need to somehow get this from the SDL. Swap chain description, this we're not going to use, and then the swap chain is our swap chain, which we're going to fill in. So first of all, we can just say here device, and that we need pointer to it. So we're just going to say get. We're going to need this window, but let's fill out this description for our swap chain first. DXGI swap chain description. Let's call it swap chain description. All right, over here, right? It says swap chain description 1, so it's new version. And very obvious, a bunch of parameters here. We're going to fill in some required ones, which are these, right? The size, format, a very common format is going to be red, green, blue, alpha, if you can see here. So it's DXGI format, red 8, green 8, blue 8, alpha 8, and then normalized. Stereo, we don't need to configure this. What we can configure further is buffer usage. So we're going to pass this, and I'm going to zoom in actually because these are very tricky to read. So it's used as render target output. So it means we render to it and then it goes to the screen. Buffer count, we're going to use 2, as I discussed. One buffer we render to, the other buffer is presented to the screen, and then in next frame they swap. Sample count, we have to fill this in. We're going to use 1 and quality 0. So it means no multi-sampling. We're going to cover multi-sampling in the future. Just to quickly explain it, it's actually kind of does blending based on sub-pixel level of your geometry. So in other words, let me try to explain this real quick. So let's say that you are rendering some triangle, right? And let's say, just for our purposes, this is the size of our pixel. It's very huge pixel. But then let's say that here we have cleared our screen to blue color, right? This is our screen, and let's say that our triangle is red. So what multisampling does is, let's say that you use 8 samples. Let's, for simplicity, say 4. And let's say that this geometry, this is not the best drawing, but you might get the idea. Let's say that, let's say, hey, we subdivided this pixel, and somehow, let's say that here we have more samples than here. Let's say that this one just belongs to red, and 3 of those belong to the background. So what it means is its blending is going to be 0.25% red and 0.75 blue. And that's how it works. So it just blends a bit better and thus reduces aliasing. So we're not going to use it yet. I just wanted to explain it real quickly. If you don't have it, you're going to see alias because then pixel is one color, right? We're going to use here discard, and then discard, I think, let's see what it means. I forgot, honestly. So it says discard is basic. La, la, la. Okay. We'll let the screen take whatever it wants. Cool. Let's go a bit further. So we create our swap chain. So we need to start filling that data in. But we still need this window handle. So for the window handle, we need to get it from the SDL actually. So there is a function SDL get window info, I believe, but it's not here. I think it's contained in different namespace. So let's try to include it as SDL2, and it's something like system. Window manager, I guess it stands for. So let's try now. Get window. Here. So we need to get info. So we need to get window info. We have our window, but we also need this info pointer. So what is it called? It's something like, let's see my notes actually. System. It's this one. So we need to fill that in. And if it does not equal to true, we want to return because we were not able to get our window handle. So you can do this kind of message and then just say SDL get error, and that's it. Of course, before we use it, we kind of need to say to SDL which version are we actually using before we call this, because it might fail. As you can see here in documentation, the caller must initialize the infrastructure version by using SDL version. So let's do that. So we just need to call this before, otherwise this might fail. It might say something like wrong SDL version, whatever. But now we can actually get that window handle. And here it is. So this is already a pointer, as you can see from the type. So we don't have to like write this because it's already a pointer. Then we need this swap chain description. This can be null pointer for default, null pointer, and finally we need to fill our swap chain. Swap chain, let get, will this work? So let's just break these parameters because it's very hard to see. I think we're good here almost, but it should be like this. I guess no. So our factory here is factory 2, which is correct. Aha! I forgot we also use new version of the swap chain. So it should be this one. As you can see here, it creates swap chain 1. So it's just a new version. It failed. We just want to throw a message. Failed to create swap chain. That's fine. And I think we're done with the swap chain finally. So I'm just going to try to run it to see if the creation failed. And as a matter of fact, it did not, so it went fine. Perfect. Perfect. So we have that. Now from here we're going to need new method, which I'm going to call retrieve back buffer, because we need to fill this back buffer and render target view, and I'm going to call this back buffer the target view. We might have different the target views in the future if we do some post-processing or stuff like that. So it gives me suggestion here. Let's see. Let me see this, if this is correct. So we want to get buffer, and we always get the first buffer. So we just pass 0, and then this interface, right, thingy. So this will create similar to this here, right? It just says UID of IDXGI, and then queries the back buffer and sets it. So this is fine. And then we also retrieve render target view with create render target view method. And this, I'm not sure if this is correct though, because we're missing some information. So here, I'm just going to remove all of this for now, because this is all wrong. So we're going to need to create that view, but first of all, we need to provide description. And then we need to provide format as well, which is as was common, red, green, blue, alpha, right? And then dimension is texture 2D. So this must be same format as swap chain. And we just say 2D texture because we're working with 2D textures. And then HR device creator and the target view. We pass pointer to the back buffer, description, and what we're filling in. So if we fail here, we just want to like put some results in. And then where we want to create it, we can create it right over here in our constructor. We might need to move this in the future. For now, I think it's fine if we create it here, because it might need to be moved at the start of our frame, but for now I think it's fine. Okay, it created both the back buffer and the back buffer and the target view. Awesome. Almost there, guys. So what we need to do now is just actually write something to this buffer that we retrieved right over here. So we're just going to clear it to some color. So it will be a single color, and then we're going to present it to the screen. So I'm going to do this like this maybe. We're going to have two public methods. This one's going to be begin render pass. And this one's going to be end render pass. So on the begin render pass, we kind of start rendering to a frame buffer. We prepare objects that we need to actually render to it. And on the end render pass, we actually present the buffer to the screen. So we're going to do this, and also we need render begin. Was it not begin render pass? It was. Cool. All right. So let's just first of all define our color. And I don't want it to be black, then we're not going to see anything. So I just prepared some values, which is light blue. I don't want something like red or very simple. So I'm going to just say here light blue. Of course, we just defined the color, we didn't pass it anywhere. So now we need to use our context and they say clear render target view. Which one are we clearing? Right, our back buffer and the target view. So for now, we're always going to actually write this one because this retrieve back buffer is created at the start of the frame. It just only once, so it might need to be here, but we're going to deal with that in future. And then we just need to paste it in render target view, and then we can say render targets. And right over here, we just need to set that render target view. We're just setting once instance. So it just takes the array of or pointed to the pointer. So we're going to do it like this. Should be simple enough. I'm just going to clean this up. So essentially we say clear it to light blue, and then we set our back buffer to which we will render to, and we just now need to present it to the screen. So we can say here present, and this is our here it says documentation right here. So if you wanna disable vsync, you can just place 0 here. So for now I just want to enable it, and if we try to run now, finally we should be able to see something, hopefully. But of course I would need to actually call those functions. So we can do it right here, and then here you would add some rendering code and then end render pass. So let's try it, and we have our blue screen. Cool. So much work for so little, but that's low level programming for you. So just to recap what we had to do, and then I'm going to showcase some stuff. So first of all, create device and context. We covered it last time. First of all, we need to configure our frame buffer. What's important, we configure it for double buffering, right? And these are just some like default values, more or less. Then to create it, we actually had to pass window handle. And then we need to retrieve the actual texture that's used by back buffer and the view to that texture. Then at the start of the frame, we just clear the contents of the texture to our blue color. We set it as to DirectX as something that we want to render to. So this is essentially saying, okay, render to this buffer right now. And then we just present it. Just to showcase this, and I'm actually going to need to do this because our frame rate is going to be 60 by default, and I need to build it. So if I go here to render doc, try to launch application. I already have our DirectX game. It's in folder, your project folder x64 debug. And if we run it, you can see that we're running at 60 frames per second because my screen is like that. That's due to VSync. If I had 120 Hertz screen, it would be 120 frames per second. But if we try to maybe misconfigure some of the stuff, let's try to do. What we're going to do is just disable the VSync. Let's try it now. And if I try to run it now, you can see that we're flying. We're rendering 900,000 frames per second. For you, it might be different, of course. So without the VSync, it doesn't wait for this refresh rate of the screen. But what happens is it's just flipping buffers very quickly, and it's drawing to them. And usually, if your game is running, you would have here it doesn't have any tearing because we're drawing the same picture every frame. But for your game, it might result in a terrible tearing, depending on your game. Of course, we could also render it with a single frame. If we're going to write at the same time in disable VSync, we could also render to a single frame. Anyway, that's it for this video. Hopefully it wasn't too hard. It's a bit complicated to set all of this stuff up, but then later on it's going to get easier once we start dealing with some texturing or just drawing our objects. So for the next time we're actually going to draw our objects. We're going to create a pipeline and we're going to render simple triangles. So we're going to get into shaders and just try to render something to screen instead of this blue color. So if you liked the video, maybe like, leave a comment, subscribe, and until next time.